Hi, everybody. This is something I have a lot of passion for. So, I'm hoping that after this presentation, you get some inspiration, especially if you're working in any kind of search atmosphere with Knowledge Graph, because I think one of the only ways to do equitable search really well and effective is with a Knowledge Graph. Okay, so what's the issue with search KGs? One of my favorite movies is The Princess Bride. You think you know what that word means, but do you actually, right? So, language is very messy. And when you are dealing with search, one of the top issues that we have is what do you call that thing? When you are dealing with people in your institution or in your company, and you're trying to make sure that your internet search, or if you have a product, your external search is working so that any user, no matter their background, their language, their dialect, they can use the words that they're most comfortable with to actually find your content. Well, how does that work if you don't know what words they're going to use? And if you have tags on your content or your assets in general, how do you make those things come together? That's where Knowledge Graph comes in. So let's start out with why does context even matter, right? Keyword strings, fuzzy matching, all of that is predicated on the fact of search engines do a lot of this already. In fact, they do language really well too nowadays. Well, here's where you can kind of see where things go wrong. So here you'll see up in the top corner, the context is wrong. So here, the word that was being queried is the same string match as a certain religious kind of sect. So they look the same, they might even sound the same, but they're not the same. Another one, this is one of my favorites, and unfortunately, you can't go and see this example anymore because Microsoft Academic, which was an open search platform for research, doesn't exist anymore, or at least it's shutting down. So maybe there's reasons for that we're going to talk about here. So when you're looking at categorical or indexed, and here I'm not talking about necessarily a search index, I'm talking about the subject tags that you often find on assets, telling your end user or your company, what is this thing about? So here you'll see that one of the top cited articles in the history field was actually not history. It was something that was dealing with medical. So because we got the context wrong, we as in the global we, I didn't work on this. This really skewed the results on who the top researcher and who the top paper or what the top paper was for that year, because it was actually a medical paper and not a history paper. Then you'll see over here that, when you're dealing with words that are commonly misunderstood, like weight, well, weight has a general understanding, but when somebody says weight, what do they mean? Are they talking about weight loss, or are they talking about the weight of something, how much it weighs? So these are just some examples of, if you're not really looking at the context and you don't have enough context to really train your machines, what are you going to do when it gets into your search engine? Okay, so a common way that we fix this when dealing with machine learning and knowledge graphs is you go and get more context. And a great way to do that is with open data. I think we all use open data to some extent. So I certainly use a lot of linked open data from the linked open data cloud. A lot of government organizations have open data as well as medical. And those are great, except they're not. When you get into the data itself, you have to be really careful with this. I have so many students that I work with right out of their computer science degrees, where they're like, I'm going to use DBpedia or I'm going to use Wikidata for everything, and it's going to be glorious. So much data. Yeah, but there's a lot of bigotry. There's a lot of, racial slurs. There's a lot of other stuff that's in there that you might not want your machine to learn from. So those are things that you want to avoid. When you are looking at some of these data sets, they're also created for general audiences, which is your audience who's using your search engine, whether it's an internal or an external search engine. Are they all general? Probably not. There are probably people from different ethnicities, people from different backgrounds that are not going to be using those generalized terms and concepts to actually do their searching. So you're probably excluding a lot of people finding something that they really want because you're just not looking at the data set with equity in mind. So some of the things that you often see in these open data sources is outdated terminology, right? So there's a lot of area that this covers, but some of the primary ones are things that deal with anything dealing with self-identity, so that's sexuality, ethnicity, that sort of thing, anything dealing with politics, anything dealing with religious or belief systems, and then anything that's dealing with what's called protected groups. So protected groups are people that are in the prison system, or children, people under the age of 18, folks that have disabilities. Those types of things are protected groups. So looking at the terminology for those areas is really a good starting point if you need a tip on where to start with improving your search engine through this knowledge graph technique that we're going to talk about today. So you also have some fuzzy relations. So if you are dealing with open data, sometimes one thing will be a different a type of something else, but is it a type or is it a part of, right? Those are very commonly mistaken when you're looking at open data. And in one data set, they can intermix all the time. Poor definitions or scope notes, bad forms such as dog -- food -- recipes. This happens a lot with open data from library systems, for instance, which I deal with a lot. So if you don't know what Ebsco is, I know that was part of my introduction. Ebsco Information is a company that creates search engines essentially for all the scholarly research on the planet. We have more scholarly research than even the Library of Congress does. So I have to figure out for a global audience what to call all of this stuff so that people can actually find it. And one of the ways that we do that is with the technique I'm going to be talking to you about today. And we are also using Neo for parts of it. And that's why I wanted to talk to you about this. When we're working with this kind of data, there's over-indexing you will also find, which is a topic such as the United States is tagged to almost every single research article in the medical discipline, because it's talking about that as the place that research was done, not what it is about. So you have to really understand what you're looking at when you're looking at those open data sets. Circular logic, that's another one. And then unfriendly context. So you'll see here in one of the images that there is a card game called Bullshit. I'm dealing in the academic space. I don't necessarily think that the students that are in high school or maybe even younger are probably looking at a scholarly search engine and hoping to find something about bullshit. And there's many different ways and contexts that you can take that. So that's something that you need to watch out for. So when you're going through these open data sources, they're great, but just watch out for these issues. Okay, so how do we actually model it? We're bringing in some of these external data sources. We also have a very large corpus of full text content. How do we model it? So there are two levels, and it's really funny because there's another presentation at Nodes that's happening at the same time that talks about the first level here. So I hope my colleagues are in that one so I can find out what they're talking about. So the first layer that we take is all the taxonomies. So those open data sets. So this could be the Library of Congress subject headings. It could be the medical subject headings. This could be Wikidata, all of those external individual data sources. It's great. You can map those together as synonymous. And so that's what the model is here that you see at the top. But that doesn't really tell you much about how those concepts match one another, how they're actually related. And that's where knowledge graph really comes into play. So all that equality, right? Going out and understanding what are all the ways that people call ADHD or ascorbic acid or vitamin C. All of those things can be mapped together in that layer. But that doesn't tell you how ascorbic acid and vitamin D relate to each other. That's where the knowledge graph comes in. And so we use some machine learning to actually get us that next piece, where we're trying to understand not just what an ontology probably tells you from, let's say, BioPortal. We're trying to understand, based on the actual linguistics of the researchers, how they feel those two things are related, because we're trying to tap into that user's mental model. That's another piece of equity, is trying to understand how people think about these topics. All right, so how do you get at the rest of equity, that mental model? Well, you got to ask your users. Now, there are a few different techniques to doing this. So one of the best ways to do this, if you are dealing with an internal search engine that's just for your company, is do a card sorting exercise. So you can do a physical card sort if you want to do that. And I'm not going to go over what a card sort is, but you can just Google it and it'll tell you how to do it. But it's essentially gathering the terminology that your end users are going to use when trying to find content or assets on that topic. And I've used this at a lot of corporations that I have worked at and that I have consulted with. So this is really helpful when you have a small group of people or a small group of stakeholders. If you have a larger company, you can still do card sorts, but you can use survey tools. There's a tool called TreeJack, which is actually really great because you can just pay for your project and not have a long subscription that does digital card sorts. But the other ways that I get at some of this information is, first, you can mine from social media, right? If you have Yammer or something else at your institution, you can gather terminology that way. Another way to do this is mining from the full text in your search logs. When somebody is typing something, that's usually the words, the mental model that they are using. And it's not always what you think it is. It's not always that controlled ascorbic acid. You would think that people maybe working in the medical field are going to use ascorbic acid, but when you're using your mental model and doing search, you usually go back to the words that you use when growing up. That's for anybody. Then when you're sitting there and you're like, what is the word for that thing? That's your mental model. And that's what most people use when they are doing search. These are the applications to get at that information. And so you can see here how we are using a few different, we're an AWS shop. So we are using a few different AWS ways to get some of that feedback from those end users. And we also sometimes use Mechanical Turk, and we do make sure to get a very strict list of who we're looking for. We don't just send it out to anybody on Mechanical Turk to get some of that terminology. So then what? All right, so I am actually going to hopefully share my screen so you can see this. I've updated this. Let's see. Is it there? Oh, there we go. There we go. Okay. So I'm hoping you can see what I see. If not, someone unmute and tell me. So I made this a little bit more detailed because I know I'm talking to a lot of folks that are using Neo4j. So you can see here up at the top, we've got linked open data as one of the resources, as well as our document repo. We are, again, using AWS. That goes on to S3. We're doing some things with Textract and Comprehend to really do some of that machine learning to get the clay on the table, right? Then this area here where we have the human in the loop, that's the slide that we just went over, where we're really working with those end users and doing card sorts and doing Mechanical Turk and just talking to people and getting the real terminology. Mining from our search logs is a really big one for us as well, to get the real terminology. And we're mapping all those together so that when someone finds that concept, they don't have to worry if they are using the right word anymore, because everyone's words are as valid. Now, you're not going to get everybody's variation. It's not going to be perfect, but it does help people, because if you tell them their word isn't good enough or it's not important enough to have in your search engine, all you're doing is blocking them and making them frustrated. So after we get through that process of mapping everything together, we are then using how they are related to each other from our full text. That creates that knowledge graph. And we're going to show you what that looks like because there's a big visual component to this. So all of that goes down into Neo Semantics because a lot of linked data is in RDF. And a lot of the control vocabularies that we have also are in RDF because they are librarian created usually. So we have to get that into a usable state. So we go ahead and get it into graph. All right, so the visual component that we have, that is another piece of our equitable search. Not everyone is a learner from text. There's a lot of visual learners out there, and a lot of the time a picture really helps someone understand context. So we have a whole visual UI that I will show you at the end of this presentation that we have built and that is powered by graph technology. So the way that that works is the user enters their query into the UI. That goes into our graph storage, and it gets picked up by our Lucene index that is also something that we have connected to Neo4j. So this whole thing down here is happening within the graph component. All right, so I'm going to continue with my slides here because I'm going to pop over in a second to show you what this looks like in practice. Okay, so let us see this in practice. Before I actually show you what it looks like on the actual product, let me walk you through what it actually is doing. So I told you that we have two levels of mapping, right? There's all the synonyms, right, which you'll see here. These are all the synonyms going in. So this is what the user is typing in. This is an end user that is a customer of Ebsco that types in, I am looking for research on plastic surgery. Well, the layer where we have tags from lots of different publishers, we have to map all of those together, and we have to map together the user's natural language. So that's what you see here. So there is a medical subject heading, which is surgery, plastic. Remember when I told you about open data not being structured well? This is the example. This does not do well in machine learning unless you do something to it. Then you see the Library of Congress subject heading, which is plastic and reconstructive surgery. Okay, that's different. If you did just a plain keyword search or even a fuzzy search, you might not actually find all the content that's tagged with this kind of content or this kind of information. Then we have a high volume natural language term. So remember I said you're not going to have every single synonym from your end users. You have to have some level of cutoff. You know, is it mentioned 50% of the time? Is it mentioned on the most highest transaction kind of information? That's really where you have to work with your team to understand what's meaningful. So here we have cosmetic surgery. All of these mean the same thing, but without the power of a knowledge graph, you can't really capitalize on bringing these all together. So this is the first layer of mapping. It's just that synonymous query expansion that we do. So this is an embedded graph. Then the second piece is the visual that I'm going to show you. And I'm going to show you both of these things too, by the way. So the visual is where we take that second mapping where we have, how does ascorbic acid relate to vitamin C? Or what are all the different drugs that interact with Zoloft, for instance? And is Zoloft the right word? I'm pretty sure there's a more technical medical term for that, but I don't know what it is. So that's the second layer of mapping that we do. And we power this beautiful visual that does disambiguation, which you see here with ADHD. You can see all the related topics here. And you can find the content right away based on that query expansion. All right, so let me go over and show you what that looks like. Okay, so this is called the Ebsco Discovery Service. This is what the company I work for creates, and I really hope the session hasn't expired. All right, so this is an example of how Battle of the Bulge, it is something that happened in World War II, has been mapped to this tag here, which is the Battle of the Arandes. So these don't look anything alike. However, these are actual synonyms of one another. And we know that from mining the full text and or because we got this from our search logs. So because we've mapped this term to this one, this article is showing up. This article is showing up. Now, they also have Battle of the Bulge in here. So this is where how you have your search engine calibrate is really going to play a part. So at Ebsco, we actually get a lot of content that does not have very good titles, or it doesn't have titles, it just says no titles. So one of the most important parts of our search engine are these subject tags, or the tags of what this thing is about. So what that means is, even though this has Battle of the Bulge, it might not have shown up. It most likely would, because we do, fuzzy matching and all of the other things that search engines do. But this content here actually teaches, remember, we're in the academic space here. It teaches students, oh, Battle of the Bulge also means Battle of the Randys. See how it's bolded? That's why we do that. It's a teaching assistance to students. Now, let's go and look at what this is in the visual aspect. So I showed you ADHD. There we go. In the screenshot. So let's go ahead and do ADHD. And you can see how we have started bolding those because we've mapped them on the back end using our knowledge graph. Then we're going to go into what we call the concept map, which you will all know what this looks like because it looks just like a graph, because it is. All right, so we're going to open that up, and here you go. So attention deficit disorder. So you can see we have images for each one of our concepts. And remember, under this concept are all the synonyms. We don't display that because it's too messy. It just makes life easier for our end users. We have our label, we have definitions, and then we also have discipline or domain that this belongs to. Now, if I wanted to add this to my search, remember, this is all to help me with my academic research. I can add it to search, and it shows up over here. And then I can look at my content preview. Oh, uh-oh. Let's hope it works. It's thinking. There we go. Okay, just needed to refresh. And here's all the content that I could find on that one topic. Now, that's no different than when I was looking at my textual search. So let's say that I wanted to add, let's see, codependent. You can see how it's related. This is the actual triple right here. And let's see, can I add it to search? Yes. Okay. So I added to search, and you can see I have a Boolean operator here, and it's updated my content. So this helps people expand the things that they are doing research on. So this is typical for college students, but this is also used by corporations that Ebsco works with. So let's see what that looks like. So let's see, Zoloft. See, there's another teaching aspect. I typed in Zoloft, which is the lay person or the natural language word for this topic. And then it tells me what the true medical terminology is. So let me go ahead and select that. And you can actually see that, oh, wow, Zoloft has a significant drug interaction with this drug. Well, that's really important for me to know. We actually work with a lot of big pharma and chemical and food engineering companies for this exact reason, because we can see the exact answer that we were looking for if we were in here trying to find the drug interactions that this had. If I went back here and did a search for Zoloft, I would do a search for Zoloft, and then I would have to read through every single article and hope that I found all of the research talking about significant drug interactions. Or I could come over here. Let me get rid of these ones here. So let's add that to search. And let's say we want to look at this topic that was mentioned. So let's explore that one. Okay, now we can see the other things that are related to that. And let's say, okay, this also looks like a good interaction that I want to add. Let's say this one. Let's add it to search. And you can see my reading list of articles that are talking about these two things together and mentioning drug interactions are right there for me. And that was what, 2 clicks, 3 clicks? And that's much easier than having to go through page after page after page of research and hoping that you find everything. So in the last remaining moments that we have, I just want to show you a few more things here. So I have always felt that part of equitable search is understanding that English is not the primary language of research. I have many colleagues, many people I've run into that feel that, oh, you just have to make sure that you cover English and maybe Spanish and French. I don't think that's appropriate. I think that we live in a global world and there's a lot of dialects, even in English, let alone other languages. And all people, including people in America, speak other languages and are probably doing research in those languages. So, this interface, remember all that natural language? Ebsco actually has the pipeline that I have in my slides for the user's natural language, human in the loop. We actually have a consortia of people all across the globe that are helping us actually get the real translations. So these are not machine translations of these topics, people that are bioengineering experts, gardening experts, people that are experts in their field telling us what the real word for this is. So let me show you what that looks like. So let's do, is it going to do this one? No. So I switch it to Spanish, and everything is in Spanish. This is not a machine translation. These are things that people have helped us get the right label and the right definition for. So this is really exciting for us. And we cover over 200 languages and dialects. Now, that doesn't mean the entire graph is in all of those languages. It means that we have concepts that have coverage for all of those languages, as well as concepts that maybe have 40 of those languages or 5 of those languages. And that's part of the natural language, is making sure that people can find information using the words they know. So for instance, if I don't know the word for cat, but I type in gato, it shows me that cat is the equivalent of that. So if I didn't know what the word was, I could go in and use the word I know to find the English equivalent. And I'm also learning things too, because gato apparently is an Argentinian music style. So let's show this with a commonly ambiguous word, Java. So you can see, oh, Java's an island. Well, I know it as a programming language. Okay, well, that's good. That's there. And so you can see all these different versions of Java in the disambiguation panel. And so if I wanted to search for that, I would click on it and it would take me to Java, and I can go ahead and add things. Now, this is not going to give me good search results. I'm going to add this, no search results because I'm searching on 2 different things. So if you search for something on pizza and then you switch over to geographic, it's not going to show anything great. So let me show you something about relationships. This is something I haven't really seen in a lot of graph interfaces that are for end users, is actually seeing those relationships. So let's do Walt Disney. Okay. So we've got Walt Disney. We can see all kinds of stuff about Walt Disney. But look how many relationships he has. So this is really cool because it's a filter. So let's say I want to learn more about Walt Disney. Well, I can just use this middle part. Or I could come over and say, how did Walt Disney die? Oh, okay. Oh, I still have it in Spanish. I know some Spanish, not enough to read that though. And there we go, a failure of cardiovascular system. Cool, so now I can add these to my search and find articles talking about how Walt Disney died. So you can see also the browse history here. Let me show you one more. COVID-19. So there you go. You can see all the different things that are related to COVID. And if this bubble thing is not your style, which we're all here, we're graph people, we're probably okay with it. But end users, sometimes they like it, sometimes they don't. So this part is still in development, so forgive bugs if you see it. But we also now have a grid view where it's kind of similar to how Netflix looks or Amazon Prime, because that's a known pattern to the UI. But you can go in here and you can look for the filter by relationships or disciplines. You can add this to search just like we were doing before. Again, there's no results because I'm making a crazy search string over here. But we can see all the relationships here. Here's the COVID symptoms, and you can go through here and look at the different symptoms. You can learn about them, and you can add them to your search. or you can expand on them. So let's see, what do we want to do here? Watch, this will break when I do it for you. Okay, so insomnia. So first of all, we are working on the images that are for grid view because they have to be bigger than the circle ones we have. But yeah, see, it just goes to the next one and you can continue to add and improve your search. All right, so I'm going to stop sharing. Hopefully you can still see me. Now I have to find my tab where you all are. There we go. Okay. All right. So I know I'm done a little early and I've walked through that pretty quickly, but I wanted to do a quick summary of the things that we've learned in this. And the first is equitable search is not about getting it right. It's about making a first step. So if you can even look at some of those areas where terminology is just really flexible and kind of waffles sometimes and can hurt people. And I went over those, religious and belief systems, identity areas, politics, that sort of thing. Those are really good places to start and get that user's natural language. Start, if you're not already, mining from your search engine, talking to your end users, doing your own card sort if you're not familiar with it, and then mapping that into your concept that you have that is your controlled concept, right? That's the thing that's going to have a UID or whatever you're using as your ID, and you're mapping everything to that. And if you already know how two things are related to each other, that's all the better. But if you're not already understanding the context from your actual text, that's something to start with to get that context. And if you don't have your own content, you can use those open source data sets. But as I mentioned in the presentation, be very careful with what you get. We actually at Ebsco have an entire sensitivity review that goes through and finds common slurs and issue kind of things, controversial things, and we mine that out because we are dealing with an academic group, and a lot of our customers are from the school and public age range, so under the age of 18. So we have to be careful what we're showing to them. But the college students, they're a little bit more lenient. So there's all kinds of weird things that you can find in the graph that college students are searching on. But it's also that language. It's the user's natural language, but it's also not just English. So if you can do that, that's all the better. All right. So with that, head on over to the next speaker.